All right. Ooh. I don't know if I did that. Okay. What are we doing? We are working on this one. So this is my maze. If you're interested in the Abacus, I do have it available in my shop. It is located here, and I just pinned it. Thank you everybody for joining. What we're going to do is we're going to read this Abacus. So we have our number. We have 7,632. There we go. There we go. 7,632. So what we're going to do is we're going to put it on our abacus. We have 7,000. All the beads that are touching the abacus is being counted. So this is counted, right? This is 7, it's counted. 5, 6, 7. When we're looking, right, none of these are counted. Why? Because none of the beads are touching the horizontal bar, this reckoning bar. Because the bead is not touching the reckoning bar, this is now 7. This is 7,000. 7, 0, 0, 0. We do 6, 5, 6. So when we're looking, we have 5, 6, 7, 5, 6, and then 1, 2, 3, 1, 2. So we're going to draw it up. We're going to color it in on our abacus. Welcome, everybody. Welcome. We have 5, 6, 7, 5, 6, and then 1, 2, 3. We have 1, 2. Right? So we have 7,632. That's what 7,632 looks like. And now we're going down to here to 6,440. So when we're looking, we have 6,440. We have 6,000, 6,000. How do I know this is thousands? Every column is a place value. So we have 6,000 is over here. We have ones, tens, hundred, thousands. We have 400. 1, 2, 3, 4. Now we have two columns being counted. We have 6,400. And then we have, what number are we doing? We're doing this number right here. And then 40. 1, 2, 3, 4. So then we have 40, and then 0 is our placeholder. Hello, everybody. Hello, welcome. We are looking to read the abacus, and then we will do some arithmetic with the abacus. So we're going to color in 6,000, 5, 6. We have 1, 2, 3, 4, and then we do it again. 1, 2, 3, 4. We don't color in this column, the ones column, because it's a 0. So that means nothing gets colored. So now we have 3,789. So we have 3,000, 1, 2, 3. This is the thousands. When we're looking, we have our place values. We have our thousands, our hundreds, our tens, and our ones. When we're looking, thank you so much for liking the live. We have 700, 5, 6, 7, 5. All the top bead is a value of 5. And then the bottom bead's a value of 1. So now we have two columns counted. We have this column that's counted and this column's counted. None of these are counted. So then we have 5, 6, 7. So notice that we have 5, 6, 7, 5, 6, 7, 8. Notice that there's one extra bead, and then we have 9. There's another extra bead. So we can kind of color it in. We have 3,000, 1, 2, 3, 7, 5, 6, 7, 8, 5, 6, 7, 8, and then 9. Hello, everybody. Hello. Thank you, everybody, for joining. What we're doing is we're reading the abacus, and after that, we will do some adding and subtracting. So the first thing we're going to do is 4,187. Hello. No, it's not 67, Tommy. It is 4,187. So we have 4, 1, 2, 3, 4. When we're looking, we have our thousands column, and then our hundreds, our tens, and our ones. When we have it, we have 4, 1, 2, 3, 4. This is 1. Just like here, this is 1. So 4, 1, 8, 5, 6, 7, 8. 5, 6, 7, 8. 5 plus 3 is equal to 8. And then we have 7. 5 plus 2 is equal to 7. So then we're going to color in our abacus. We have 4, 1, 2, 3, 4. We have 1. We have 8, 5, 6, 7, 8, and then 7. Notice 7 is one less bead. Because it's one less bead, that makes it 7. If this is 8, one less bead is 7. So then our next number is 209. Hello. Hello. So we're having 209. 200, our thousands, our hundreds, our tens, and our ones. We're going to do 200, 1, 2, 0, and then 9. Well, how do you get 9? 5, 6, 7, 8, 9. This is our ones, tens, hundreds, and thousands. Welcome, everybody. Welcome. Thank you so much for sharing my live. What we're doing is we're reading the abacus, and we're taking this number and we're putting it over here. So we're going to color it in 1, 2, and then we have 0, and then 9. 5, 6, 7, 8, 9. There we go. And then what do we have? We have 1,333. We have 1,333. 1, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Now if you look, we have our place values. We have our 1s, our 10s. Explain so easily. Thank you. I appreciate that. We have our 1s, our 10s, our thousands. I'm sorry. Our 1s, our 10s, our thousands, and our hundreds and our thousands. So when we're looking, we have 1,333. Do you know it? Do you know how to use the abacus? We have our 1,000, and then we have 3. 1, 2, 3. 1, 2, 3. 1, 2, and then 3. What is our next number? Our next number is 9,000. Oh. Whoa, whoa, whoa. Our next number is 9,000. Okay, 9,265. So we have 9,265. So what are we going to do? We're going to look at the abacus and notice that these columns are being counted. These columns are touching the reckoning bar. So we have 9, 5, 6, 7, 8, 9. We have 2, 1, 2, and then 6, 5, 6, and then 5. So notice we have 4 columns that are being counted. 9,265. So now what I'm going to do, I actually don't. Oh, interesting, interesting. Yes, you can do abacus. You can do adding, subtracting, multiplication, and division on the abacus. I just asked because, yeah, some people know it, some people don't. I do have a few people that know how to use the abacus, and they join my abacus, my lives. Yeah, it's fun. But yeah, we will be doing some, we will do some adding, subtracting, multiplication, and division on the abacus, but it just depends on time. So we're going to continue on with 6,227. So again, we have 6,227. This means that I have these 4 columns being counted. Every column is a place value. When we look, we have 1s, 10s, hundreds, thousands. So when we're looking, hello, Lexus. Thank you so much. First row all colored. This is 1s, if that's what you mean, right? So this is 7, 5, 6, 7. This is 2, 1, 2. This is hundreds, 2, 1, 2. And then this is 6, 5, 6. Does that make sense, Lexus? Thank you so much for commenting. So we have 7, 5, 6, 7. We have 2, 1, 2, 1, 2, and then 6, 5, 6. All the blue beads. I answered the last problem. All the blue beads is counted as 5. So our next number is 1,801. So when we're looking, we have 1,801. So what we're going to do is we're going to understand that this is the 4 columns that are being counted. We have 1 here, here. This one is a 0, and then this one is a 1. So what do I look? I see 1,000. We have 800, 5, 6, 7, 8, 5, 6, 7, 8. We have 0, and then we have 1. That's what 1 looks like. Do I speak Mandarin? No, I'm speaking English. I'm not sure if you understand. So we have 3,477. So we have 3,000, 1, 2, 3, 400, 1, 2, 3, 4, 7, 5, 6, 7, 5, 6, 7. So we have 1,477. When we're looking, we have our place values. We have our 1s, our 10s, our hundreds, and our thousands. So, wow, thank you so much for helping. Thank you so much for helping. Yes, so we have 3,000, 1, 2, 3. We have 4, 1, 2, 3, 4. We have 7, 5. The top beat is 5, 6, 7. And again, 5, 6, 7. Thank you so much. I know I answered it. Oh, right. All right, so we have 5,447. So we have 5,447. When I'm done with this, it will be your turn to let me know what the answers are. So we do 5,447. So we did 5, The top beat is 5. We do 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 7. 5, 6, 7. And then our final number is 3,630 with a 0. Don't forget the 0. The 0 is our placeholder. That tells us that there's the ones, but there's nothing at the ones. So when we answer it, I'm going to color it in. We do 1, 2, 3. We do 6, 5, 6, and then we do 3 again. 1, 2, 3, and then 0. So if it's 0, we don't need to color in the column because it is 0. All right. No, it's not 6,000. It is not 6,777. That's not right, David. And Owen, that is not 6, 7 either. 6, 7 is 6 and then 7. Right. So for those of you that just joined, thank you so much for joining. What we're going to do is it's going to be your turn now. Let's see how well you answer this. Let's see if I can find it. Okay, we'll do this. All right. So for those of you that just came on board, we're going to do a review. Let's do a review. Okay, for those of you that just joined, here is a review. What we're going to do is we're going to read the abacus. We do, there it is. There it is. So we have 1, 2, 3, 4, and then 5. All the top beat is a value of 5, just as mentioned here. And I pinned it in the comments. Thank you. This is still a thing. It is a thing, and there's a competition to it. Thank you, Arturo. Yep, there's competitions in it, and it's pretty lively. Not in America, though. So I'm here to show the matrix what an abacus is. This is 5. We have 1, 2, 3, 4, and then 5. All the top beat is a value of 5. We have 6. Notice we have 1 plus 5 is 6. We have 7. 2 plus 5 is 7. 3 plus 5 is 8. And then 4. 4 plus 5 is 9. And then we have 10. 10 looks like that, just like how we write. So we have tens, right? We have 1, 10, 100, thousands, 10,000s. That's it. So for those of you that are keeping up, what number do you think this is? So we have our thousands, we have our hundreds, tens and ones. What number do you think that is? Let's see. Anybody know what number? Bueller. What number do you think this is? There we go. Thank you. Thank you. War. 5,412. Well done. Almost. Sasquatch. Almost Sasquatch. So we have 5,000. Yes. 400. 1, 2, 3, 4. 12. 1, 2. This is 2. Yep. See. I figured. Because you got the numbers. 5,000 for... Okay, got it. Good. So we have our next number, right? That's my path, and now I'm my next number. What number do you think that is? So we have... Hello, Adriana. Hello, Sasquatch. Thank you. Thank you, Benjamin. Nice. Okay, we have our thousands, hundreds, tens, and ones. What number do you think that is? We have our thousands, hundreds, tens, and ones. What number? Thank you, Adriana. Yes. Thank you, Embar. Yes. Thank you. Yes. Well done. We have 2,801. Well done. Thank you, Adriana. Thank you, Embar, and yes, and Sasquatch. Okay. So we have our next number. We have our thousands, hundreds, tens, and ones. What number do you think that is? What number do you think that is? Thank you so much for the gift. Okay, how are we doing? Yes, thank you. It is 800,066. Well done. Easy, right? Easy. So 8,000 8,066. So our next number is, what we're doing is we're reading the abacus, and then after we do this, we're going to learn how to add and subtract. So we have our thousands, our hundreds, tens, and ones. What number do you think that is? Thank you, Amber, Adrian, Adriana, War, and thank you for the follow. Thank you, Chess. Chess, it is not 3. Thank you. Yes, it is 2,445. Well done, well done, well done. And then we have our next number. What number do you think that is? We have our thousands. We have our thousands, hundreds, tens, and ones. Tens and ones. What number? Can you tell it? Because I have no idea. Well, if you watch a little bit, you will find out, because I explain every number. Thank you, War. Thank you, Adriana. Thank you. Hello, Maria. Welcome. So we have 3, 1, 2, 3. The top bead is 5. So you notice we have 4 columns that are being counted. We have this, 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 and this. Column 1, column 2, column 3, column 4. When we're looking, we have the top bead is 5. So the value of 5 is here. But notice the 5 is not touching, so it's not counted. So this would be 3. 1, 2, 3. So we have 5, 5, 3. 3, 5, 5, 3. Well done, everybody. Well done. So then we have our answer, 3,553. And we have our next number now. Hello, Taste of Paradise. Welcome. Thank you so much. Right. Thank you for the follow. So what's our next number? We have our thousands, our hundreds, our tens, and our ones. We have our thousands, our hundreds, our tens, and our ones. What number do you think? Yes, thank you, Sammy. Yes, Sammy, Adriana, and yes, thank you so much. Level 16. Yes, well done. So we have 1,997. How did I get that? We have 4 columns are being counted. 1, 2, 3, 4. And then this is 1 because this bead is the value of 1. And this is touching the reckoning bar. This is also touching the reckoning bar. Notice the 5 is touching the reckoning bar, so this is counted. So we have 5, 6, 7, 8, 9. And we do it again. 5, 6, 7, 8, 9, and then this one is 7. 5, 6, 7. Notice that these beads touching the reckoning bar is counted as 7, not counted as 9. It is counted as 7. These 2 beads are not counted. These 3 beads are not counted. So when we're looking, we want to pay attention to the beads that are being that are in contact with the line, that's in contact with the reckoning bar. Thank you, everybody. Thank you, everybody. This is fun. Oh, good. Good. I'm so happy. Thank you for the... yeah, it's not that complicated. It's super easy. Simple to use, easy to understand. Okay, great. So, thank you, Adriana. We have what number? We have our thousands, our hundreds, our tens, and our ones. What number do we think that is? Thousands, hundreds, tens, and ones. How are we doing? Would it make sense? This is okay? We're okay? Thank you, everybody, for joining. Thank you, everybody, for joining. We are still learning how to read the abacus. Thank you, Adriana. Yes, it is 7,628. For those of you that are interested, my name is Lynette, and we are learning the abacus. I am an abacus teacher. Okay. So we have 7,628. Well done, Adriana. Well done. And we're going to go here. And this is our next number. So we have our thousands, hundreds, tens, and ones. What number do we think that is? So we have our thousands, hundreds, tens, and ones. When we're looking, we notice that we have the top bead is touching. So that's what's being counted. So this is getting counted. So this is counted, this, and these are counted. Why are they counted? Because because the beads are touching the reckoning bar. This is the reckoning bar, these are the beads, right? If you notice, I have, thank you, Adriana, we have 6,000, 5, 6, and then notice we have 3 beads that are not counted. So that's why this is 6. We have 2 over here. These 2 beads are not counted. We have 1 here. These 3 beads are not counted. And then we have 8. 5, 6, 7, 8. This one bottom bead is not being counted. Thank you, Jans. Thank you, Jans. Yes, thank you, Jackson. So it's 6,218. Well done, everybody. Well done. So we have, that's the answer, 6,218. What is our next number? Thank you, everybody, for joining. Thank you, everybody, for joining. Hello. Hello, hello, hello. I have 600 likes. Thank you, everybody, for joining. So we have our thousands, hundreds, tens, and ones. What number do we think that is? Oh, Carlos, thank you. Jans and Adriana, yes. So we have 1,158. Well done. Because what? This is 1, 1. These are counted, and then this is counted. This is also counted. So these beads that are touching the reckoning bar are being counted. So it's 1,158. Thank you, Carlos. Thank you so much for the likes. Thank you so much for the likes. I appreciate the likes if it's available. I'm hoping everybody's having fun because what we're doing is we're learning how to read the abacus, and this is my maze that I've created so it's easy for you to understand how to use the abacus. We have our thousands, our hundreds, our tens, and our ones. If anybody is interested, I do have books available. I do have abacus books available in the TikTok shop. I also have it available here. My name is Lynette, and I've been teaching abacus for about 20 years now. So, thank you, everybody. How do you mark the numbers at the end of the... How do you mark zeros at the end of numbers? Haha, this is it. Because we have 3, 8, 1, and 1. So we have 3,811. Well done. So thank you, Mike, for the question. If I needed to have a 0, let's say we have 3,000. Let me get a paper. So if we had, the question is, where's my, sorry, trying to get paper. So we have our question, right? The question is what happens if it's 3,000? Let's do 3,810. So if I need to do 3,810, it would look like this: 3,801 and then 0. Why? Because every column is a place value. So when we're looking just like this, we have our ones, our tens, our hundreds, our thousands. We have our ones, our tens, our hundreds, and our thousands. Does that make sense, Mike? So that's how you mark 0. What is our next number? Oh, there it is. We go down here. Yes, thank you. Oh, good. Oh, good. Let me know if you have any more questions, but those are really good questions. It's a really good question. So let me know if you have any more questions, and we're going to go to the next number. We have our thousands, our tens, thousands, hundreds, tens, and ones. What number do we think this is? What number do we think it is? We think it is a 4-digit number. Oh, yes. Thank you, Carlos. Thank you, Jans. Oh, I think my friend left. What is this used for? It's used for counting. That's really what it is. Thank you, Adriana. Yes, 2,695. How did I get that? 2, 1, 2, 5, 6. Together is 5 and 6. This is 6. Because it's touching the reckoning bar, this is 9. Because the beads are touching the reckoning bar, this is 9. How do I know? 5, 6, 7, 8, 9. This is 6 because these 3 beads are not being counted. These 2 beads are not counted. So it's 2, 6, 9, and then 5. This is a value of 5. The top bead will always be a value of 5. When we look, these 4 beads are not being counted. So we don't count it as the number. So we see 2, 6, 9, 5. Well done, everybody. Yes. So the blue bean counts. Yes. Thank you, Yazdi. Yes. Exactly. So our our answer is 2,695. When the top bead touches the reckoning bar, it gets counted. So if you notice, this is 2, but then when I do this, now we're at 7. right? Does that make sense? I generally got interested because I never learned how to use the abacus. Oh, great. Thank you. I'm very happy I can help. Okay, so our final answer is what? What is our final answer? So we have our 4 digits, thousands, hundreds, tens, and ones. What number do we have? We have our thousands, our hundreds, our tens, and our ones. What number do we think this is? Me too. I saw this in my FYP. Hey, Krayla, welcome back. It's been a little bit. Thank you, Yazdi. When was the abacus invented? Probably before Christ. I don't know, 500 BC. I hope you're doing well. I am doing well. Thank you so much for asking. Thank you, everybody. Yes, it is 4,914. Yes, it is. Thank you. Hey, Triple J, welcome back. Wow, I feel like it's a little reunion now. Nom nom. Thank you so much for checking in. Thank you guys for checking in. For those of you that are interested, please click on the orange heart to check in. For those of you that are interested, we're learning how to read the abacus, and the abacus is the great thing. Oh, thank you so much, Jen. Thank you so much, Jen. All right. So for those of you that are interested, my name is Lynette. I've been teaching abacus for about 20 years, and I have books available in my TikTok shop. Also books available in over here. My name is Lynette. Hello. All right. So for those of you, I missed being here. Aw, really? I missed you here. I missed you too. It's just so funny. Like, anyways. But you know what? You already probably know how to use the abacus, so then you're already done. All right, so for those of you that are interested, what we're going to do is we're going to understand how to move the beads. Because we're moving the beads, you'll notice that the beads have an edge. Because there's an edge, what we're going to do is we're going to just use the edge. You don't need to be aggressive. We don't need to be aggressive, because if you're aggressive, then your answer's going to be wrong. All wrong. And then the other thing is you don't want to do is you don't want to flick. So if you do this and you flick, then your answer will become wrong.
And flick. Oh, you flick too hard, damn it!
Don't flick, because your answer will be wrong. So what we want to do, hey, Char, welcome back. How are you doing, Char? Yeah. So thank you, everybody, for joining. Thank you, everybody, for joining. Please keep your mind open for something different. It is not new. It's just different.
Now, open your mind to me, please. Open your mind.
Thank you guys, everybody, for the likes. Thank you so much. And thank you, Adriana, for the follow. So what we're going to do, again, is we understand that we don't need to... Oh, you want to hold and stabilize the abacus, because if it gets moved, then your answer will become wrong. So do you use this to count things from left to right because of place value? Yes, I did mental math. Thank you, the abacus. You can actually, Yazdi, you can actually do addition, subtraction, multiplication, and division on the abacus. And Char was doing abacus. That's funny, Char. That's really good. That's really good. It's a different way of thinking, right? Like, it's a lot easier. It's so crazy. It's so crazy. So yes, Yazdi, what we can do is we can do adding, subtracting, multiplication, and division on the abacus. But we use this tool to help us count our numbers. That's it. This only helps count our numbers. It is helpful when I can remember it too. Yeah, it is helpful if you can remember it. But it takes time, right? I mean, you've only been doing this for, what, a couple of weeks now? A couple of weeks? A couple of months now, right? Anyways, so we talked about moving, we talked about this with no flicking, and you can use your left hand. Even if you're left-handed, you want to use your left hand to hold it, and then you will use your right hand to do the calculations, because they say that the left brain is connected to your left hemisphere. Left hemisphere is connected to your right hand, which is connected to your abacus. So, thank you, everybody, for joining. Thank you, guys, for joining. Thank you so much for the likes. Wow. You guys are awesome. Okay, so please, again, keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Okay, so what we're going to do is we're going to continue on learning how to move the beads. I understand the concepts, but I don't remember that I can use the concepts without the physical item. It's really fun, though. Yeah, you don't need the physical... Well, you know what, though? You could have a printout. Did I show you this printout? You can have a printout. You can actually draw it. You can start drawing your own, and you could do it on your own. So you 6, plus the 2, plus the 9, take away the 10. You know what I mean? So you could draw it, if that would help. You don't need the physical thing. You could use it as you can have it just a little picture, and just have the little picture keep track. Yeah, you could do that too. Easy, right? I mean, these are all pictures. So you could do that too. And then, you can practice your art skills. All right. So thank you everybody for joining. This is the abacus. What we just did is we talked about what the beads are and everything. And then this is just a little flip through of my preschool abacus book for kids that are usually 3, 4, and 5. I was thinking 3, 4, and 5. Which bundle do you recommend for a beginner? I actually have a book out that's for adults. But I just published it, and I haven't gotten it yet, if that makes sense. If you want to wait a little bit, if you want to wait like 3 days, thank you Nom Nom for the heart puff. If you want to wait like a couple of days, it will get approved. I'm telling you. And then I'll have it in my TikTok shop. But for right now, it's right now being reviewed. So yeah, you're in luck. I do have it within it'll be within about 3 days. Thank you, Yans, for the follow. Okay, so let's talk about the abacus, and then you'll see how it's easy. And then yeah, unless you want you could do the mazes on your own. If you want to do that, you have these mazes, and these mazes are just bead recognition. And the idea was for this one is the tens. So you could do the tens and the ones. You could do the hundreds and the hundreds, tens, and the ones. And what we did is the thousands. And that's a different book. This is a 4-digit one. And so I started off with this is the path. And so what it is you're supposed to color in the number. So that's one way. The other way we did it is you have to tell me what the number is. And again, it's another maze. It's a different type of maze. So there's 2 types of mazes in the book if you're interested in the book. So these books, if I know adults have purchased these books as well, just to do some numbers. It's up to you. It is available here in my TikTok shop. It is also available in the other store. And this one's all done. Oh, and then the other thing is I do have the answers in the back just in case you forgot. All right, just in case you don't know, I do have answers in the back. So those are available if you want to start now, or if you want to start adding and subtracting. It is up to you. I do have a few available. Yeah, the mazes look fun. Yeah, I have some really good feedback that the mazes are super fun. And so if you want to start it with that, then I pinned it into if you want to do the 3 digits, and I also have a 2-digit as well. But the 4-digit is still coming in. I have to restock it. If you're looking for 4-digit, it is available over here. Yeah. The other thing is I sell 2 types of abacus. I sell this one, which is kind of nice because it's nice and colorful. Some people like this. I know adults like this. The kids like it too. But sometimes you want to go with a 13-column abacus. A 13-column abacus works exactly the same as the colorful one. It just means that it's just longer. Depending on how far you want to go, you can actually do multiplication and division. It's a little bit harder to do it on the colorful one, just because you don't have enough space. But you can do it on the 13-column one if you're worried about if you want to go that far. But yes, you could do adding, subtracting, multiplication, and division on the abacus. And then what we do is the same thing. So if I line it up, so notice I'm going to line it up, this dot here and this dot here. We can count 1, 2, 3, 4, 1, 2, 3, 4, 5, 5, right? 6, 7, 8, 9, 6, 7, 8, 9. That's it. So I would use this one. I would use the 13-column one for bigger numbers and for multiplication and division, because we use a lot of the abacus when we do multiplication and division. All right. So yeah. So this book here is available as well. This is available in my TikTok shop, and it comes with an abacus. there's one bundle that comes with an abacus. I do what so for right here is we talk about from 0 to 4, and then I have activities. I also have color by number, and I have pixel art. I thought that was kind of cool. And then we have counting, and then we start talking about 9 to 5, and this is lesson 2. They just need to understand what 9, and so the idea here was just the kids to get used to understanding what the numbers are. Hello, Robert. Welcome. Thank you for the follow. So we have color by number. We have our 2, right? And then here we have the abacus. We notice that the numbers and how it relates to the abacus. And then we go into how to count forwards, and then we talk about how to count backwards, right? And this is just about the relationship of the numbers. We have, what comes in between. So if I give you the number, if you give you these two numbers, what comes in between? And then we have what comes surrounding. So if I have another number, if I give you the number, we need to understand what the surrounding number is. And then after that, we count which one's bigger and which one's smaller. And that's what this is. And that's it. So now we're getting to the part where we're going to be adding and subtracting. For those of you that are interested, so that's the book, and the book is about 200 pages. So it's not a small book. It is pretty hefty. So in Abacus World, thank you everybody for joining. In Abacus World, what we do is we focus on the second add-in, the second number. The second number is what dictates whether or not we're going to be adding or using a formula. So here's my question. Well, thank you, Robert. So what we're going to do, it's probably because I talk really fast too. So here's my answer, my question. My question is 7, 5, 6, 7. Notice that the answers are being, notice that the beads are being counted. This is the ones place. Because we're at the ones place, I want to be able to add the 1. Can I add the 1? Yes, we can. Yes, I can. I can add the 1. So my final answer is 9. Nope, not 9. It's 8. 5, 6, 7, 8. 8. So when we look, this is 8. We have 9 over here. That would be 9. But when we look, we're adding the 1 over here. I've been hiding in the shadows every night. That's all right. That's all right. There's a lot of people that get scared to just even comment. But I hope that it's okay for you guys to comment because I enjoy having conversations with everybody. As long as it's all about abacus. Okay, so here we are. A little bit confused. That's okay. Here we go. We're going to do a review. Let's do a review for Plaforma. Nope. It's fun getting the right answers. It's okay. You know what? It's fun to getting the right answers, but it's okay to get the wrong answers because then we can go back and review. Hello, Asha. Hello. Welcome. So what we're going to do is we're going to review 1, 2, 3, 4, 5. All the top bead is a value of 5. Anytime the beads are touching the horizontal bar, anytime the beads are touching the reckoning bar, that's what's being counted. So we have 5, 6. Notice we can decompose. 5 plus 1 is 6. And then 5 plus 2 is 7. 5 plus 3 is 8. And then 5 plus 4 is 9. When we're looking, if I did this, this is 8. Notice this bottom bead is not being counted. So this is being counted, this is not being counted, and then it's the reverse. This is 7. These two beads are not counted, so don't count it as part of the reckoning bar. So when we're looking, we have 10. 10 is a 1 and a 0. How do I get 1 and 0? Because I have a place value. Every column is a place value. We have our ones, tens, hundreds, thousands, and 10,000s. Okay, so we're going to continue on to adding. When we do adding, we have 7 on the abacus. I want to add the 2. Can I add the 2? Yes, we can. Yes, I can. I can add the 2. Thank you, Kryla. We want to add the 2. 1, 2. Put it together like that. That's what we're doing. So then our answer is 9. When we look, hello, me. Thank you, me, for following me. Anyways, sorry. 9, 5, 6, 7, 8, 9. These beads are being counted because they're touching the reckoning bar. So when we're looking, these ones are not touching the reckoning bar, so we don't need to count it. This would be 0, 0, 0, 0, 0, 0. This is 9. So what if I did this? 9, 9, 9, 9, 9, 9, 9. They're all 9s. So it'd be 99,999.99. There we go. Thank you. Tasmania. So then we're going to do 3. Notice what we're doing is we're following the second number. The second number is what counts whether or not we can, if we have enough beads to add. When we're looking, right, I want to add the 5, I want to add the 3. You could do the traditional way. You could do the matrix way. You could do doing the dots, or you could do the tallies. It is up to you. I like to do it the Abacus way, so I'm going to add my 3. When I add my 3, I'm going to take these 3 beads and I'm going to move it up to the reckoning bar. Now my final answer is 8. You will notice that I can actually scale it. If I want to do 50, right, that's 50, 50, plus 30, 30. Now I have 80. Now I can scale it. So what happens? You could do a whole lot of dots, but that's a whole lot of dots, and I'm actually quite lazy. So I don't want to do those dots. What I would rather do is just use my abacus. I could do 500 plus 300 is 800. And so what we're doing is we're understanding that every column is a place value. Every column shows me the number. So this is 800. So what's the next number is 4. So we have our abacus. We have 4 on the abacus. We have 5 on the abacus. I want to add 4. To add the 4, it's these 4 beads. 1, 2, 3, 4. It doesn't, that's what it is. And my final answer is 9. Now, if you know how to add, you will know how to subtract. We have 9 on the abacus. What we want to do is we want to subtract 1. Take away the 1. That's all we're doing. We're taking away the 1. When you take away the 1, it is no longer being counted as part of the reckoning bar, just as we had before. So my final answer is 8. You can do it again with the 2. Again, if I have 3 on the abacus, I want to take away the 2. I want to take away these 2 beads. So my final answer is 1. And then we could do it again with the 3. We add 4, and when I take away the 3, take away 1, 2, 3. It doesn't matter if it's these 3 beads, or it doesn't matter if it's these 3 beads. It just matters that you do the 3 beads, right? So what we do is we take away the 3. So my final answer is 1. And 4 is 4. So then our next number would be 5. 5 is the top bead. So when we're looking, we have, let's do this, 3. We have 3 on the abacus. We want to add the 5. That's all we're doing is we're adding the 5. We add the 5, we take away the 5. Notice when we add the 5, it's now being counted because it's touching the reckoning bar. And then we do 6. 6. So we have 1 on the abacus and we have 6. We bring it together like that. We take it apart. So notice if you know how to add, you know how to subtract. When we add, you add 6. My final answer is 7. If I want to subtract 6, I have 1. And then what are we doing? That's 6. We're at 8. We're at 8. Okay, good. So you have 1 and then 8. 5, 6, 7, 8. Bring it together and then take it apart. Bring it together or minus the 8. Plus the 8, minus the 8. And that's it. How are we doing?
Oh, I love it. Great stuff.
Anybody have any questions? So far we're going into adding the 5 and taking away the 5. So we have the 7 plus the 1, take away the 5. My answer is 3. Thank you. Thank you, Pluriforma. I don't know. I got lost, but I got it. Okay, so we're doing it in? No. We do 5 plus 4, take away 7. That's it. All right, so here's a question. Just say pull. PL? I'll have to just say PL. Oh, okay. All right. Okay, yeah, so that's it. That's it. So what happens now? Well, what happens now? Well, what happens when there's not enough beads? So thank you everybody for joining. Thank you everybody for joining. My name is Lynette, and for those of you that are interested, I do have books available on the abacus, and they're all just about abacus. What we're doing is we're adding, subtracting, multiplying, and dividing. But the first thing we're going to do is what? We're going to understand what happens when we don't have enough beads. When does that happen? Well, oh, PL. Okay, thank you. Okay, so, oh, what happens when there's not enough? Okay, what we're going to do is we're going to start understanding this concept. This concept is 4 plus 1 is equal to 5. Now, when we're looking, we want to understand how to make a 5. Why? Because we need to understand how to plus the 5. Why? The question, it's all it depends about the question. If I have the 4, the question is 4. When I want to do it, I don't want to memorize what 4 plus 4 is. What I want to do is I want to understand the concept. So this is a concept. I know this is super easy for you guys, but I just need to tell you what the concept is, right? I'm trying to explain what the concept is. If I have a bigger abacus, if I have a bigger number, then you guys might get confused. So that's why I bring it down to something very manageable chunks. We know what 4 plus 4 is. I understand you know what 4 plus 4 is, but we've memorized it. What I want to do is I want to actually start utilizing it for the thing. So here's my question. 4. I have 4 on my abacus. I'm going to have 4. Oh, there's my money. There's my money. So we have 4. So 1, 2, 3, 4. 1, 2, 3, 4. I want to add another 4. Because I want to add another 4, guess what? I can give you this 5. Because I can give you this 5, that's too much. I need to take away 1. So I took away 1. My final answer is 8. 5, 6, 7, 8. I could do it again on my abacus. Add the 5, take away the 1. And my final answer is 8. What level is this? This is the fun level. I'm not sure what that means. It's the beginning level. It's the beginning level to understanding everything about abacus. Okay, so what's next? Well, what happens when we have 3? 3 on the abacus, 1, 2, 3. We have 3. And again, I want to add the 4. So what we're doing is we're practicing how we do 4. Can we do division or something? No, not right now. So we do 4. When we add the 4, I'm going to add this 5. That's too much. I need to take away the 1. So my final answer is 7. 5, 6, 7. So my final answer is 7. 5, 6, 7. And I take away the 1. So what did I do is I added the 1, added the 5 to take away the 1. And I can do it again. What is an abacus? An abacus is a counting tool. That's what it is. And so when we're looking, it's just keeping track of our numbers. So let's do a little review for Safno. 1, 2, 3, 4. Thank you, PL, for the question, for the answer. This is 4. 1, 2, 3, 4. This is 5, 6, 7, 8, 9, and then 10. Because we have 10, we could do 11, 12, 13, 14, and then 15. 16, 17, 18, 19, and then 20. Safno, does that make sense? So what we're doing is we're just counting on the abacus. That's it. The abacus just tracks your numbers. The abacus just shows what the numbers are there, what numbers there are. That's it. Okay, so we can do it again with the 2. So here's my 2, 1, 2. And then I want to add the 4. Notice, if I have 2 on my abacus, I want to add the 4. I don't have enough beads to add the 4. There's no more loose beads. I cannot add it here because this would be my 10s. This is my 10s. So what I'm going to do is I'm going to add the 5, take away the 1. I need to add the 5, take away the 1. And so my final answer is 6. Oh, thank you, Urban, for the tiny diny. We all right? Make sense? So what we're doing is we're understanding how to use the abacus. And then we could do it again with the 1. The 1, there we are, the 1. So we have 1 on the abacus, and again, all I got to do is just give you the 5 nickels, my nickel, my 5 cents. But then what happens? That's too much. I need to take away 1. So I take away 1. And so my final answer is 5. I could do it again on my abacus. Add the 5, take away the 1. And my final answer is 5. What is this used for? It's used for addition, subtraction, multiplication, and division. Thank you, Sharon.
Oh, I love it. Great stuff.
Safno, did that answer your question? Okay, so thank you, Sharon. Yeah, right? Makes sense.
Oh, I can see everything.
So when you're looking, we're not memorizing, right? We're not memorizing. What we're doing is we're understanding how to move the beads. So when we're looking at it, here, we're going to do the next number. 3 plus 2 is equal to 5. 3 plus 2 is equal to 5. 3. So if you look, we have 3 right here. We're going to do it again. It's the same concept, but different numbers. So we have 4 on the abacus, 1, 2, 3, 4. Guess what? I don't have enough beads to add the 3. If I don't have enough beads to add the 3, what do? I have to somehow do something with the 2. If I give you 5, we know that's too much. We need to take away 2. So my final answer is 7. 5, 6, 7. I wish my teachers were this involved in school. Thank you. 405, thank you so much. I appreciate that. So we could do it again with the 3. So what are we doing? We're not counting up and we're not counting on. What we're doing is we're taking a concept. This concept is 3 plus 2 is equal to 5. This concept is 3, right? We're taking the 3 and we're going to change it, right? We're going to do some modification.
You need modification! Modify!
We're not going to add 3 more. What we're going to do is we're going to use the concept of adding the 5. We add the 5, but that's too much. We need to take away 2. So I take away 2. And then what do we do? 6. 5, 6. I could show you on my abacus. I have 3 on my abacus. I'm going to add the 5, but I have to take away the 2. So my final answer is 6. 5, 6. And then what are we doing? So then we can do it again. We have a whole set. We got to do it again for the 2, and we could do it again for the 1. So we do it again for the 2. So we have 4 on the abacus. We have 4 on the abacus. 1, 2, 3, 4. And then what? We want to add the 5. No, we want to add the 2. But because we're adding the 2, we don't have any more loose beads. We don't want to do this because that's 24. What we're going to do is we're going to add it here, but notice I have this 5. So we're going to add the 5, but that's too much. I need to take away 3. 1, 2, 3. So I take that away, and my final answer is 6. 5, 6. I could do it again on the abacus. I add the 5 and take away the 3. So my final answer is 6. Hello everybody, hello, thank you guys for joining, thank you for joining. My name is Lynette and we're learning how to read the abacus. For those of you that are interested, I do have books available in my TikTok shop or the abacus itself. For those of you that are interested, yeah, alright. Hello everybody, hello. So for those of you that just came in, let us do a little review. We have 6 on the abacus right now. Notice that this is the bead that's this column is being counted because these 2 beads are touching the reckoning bar. These 3 beads, 1, 2, 3, are not touching the reckoning bar, so that's not being counted. So we have 1, but we add the 5. Now we have 6. 5, 6. We have all special levels of education. Hey Sharon, did you use the abacus for special education? I wonder. Welcome, Sharon. Yeah. Thank you, Safno, for the question. Yeah, because I know the abacus is used for accommodation or it's used for enrichment program. And so I came about and I was like, you know what? The ordinary people need to use this. So I'm trying to instruct everybody else. I'm trying to show the abacus. I'm trying to show the matrix what an abacus is. Thank you everybody for joining. Thank you everybody for joining.
Welcome to the real world.
So for those of you, oh right, did you do the 10 bead or was it a 5? Was it a 5 bead or was it a 10 bead? Are the yellows or all the same value? Yes, Sunny, it is. You're absolutely right. So we have 1, 2, 3, 4. 1, 1, 1, 1. That's what that is. And if I did 5, that's what 5 is. The top bead is always 5, and then we have 6. 7, 8, 9, and then we have 10. That's what 10 is. Another example to explain the abacus. Yes, Mai, I am. Oh, here's another example. Hi, Mai, how are you doing? Did you see? Oh, this one's a better one. This one might be better for your kid. I don't know if this would. Yeah, this would be cool. So here's another example. Oh, here, let me do. I'm doing well. So, okay, let me talk about the change, right? You could talk about the change, but depending on how old the kid is, right? And how old your child is, but they might not deal with money. So you could do 4, 1, 2, 3, 4, and then 1, 2, 3, 4. You do plus the 2 is plus the 10, plus the 5, that's too much. And then take away 3, 1, 2, 3. You could do that. Add the 5, take away the 3. You could do that. I was thinking an example would be pennies and a nickel to show the value. Yes. Here's another one. Here's another one. This is the really good one. So we have 4 in the abacus, 1, 2, 3, 4. I have a package, right? I cannot add 2. I need to add 2. I have a package. This package is worth 5. 1, 2. I'm going to use these 2 beads, right? If you could see, I'm going to use these 2 cubes. But guess what? I need to remove these 3. But they're stuck together and it takes too much energy to remove it. But guess what? I have these 3 that I could take away. Because I'm only using these 2, I need to take away these 3 beads. So I'm going to take away 3 beads, 3 cubes, and then I'm left with 6. 5, 6. You could try that. Mostly 10. Oh, interesting. I was thinking another example would be use 4 pennies and a nickel to show the values of the beads. Yes, you're right. So you're absolutely right. You could do that. You could do 1, 1, 2, 2, 3, 3, 4, 4. And then 5 would be this. That's what 5 is. 6, 6, 7, 7, 8, 8, 9, and then 9. Oh my, before I forget, if you don't have the cubes, that's fine too, because I found another way, but it's a little darker. That makes sense. Thank you, Robert. I have another one. Okay, so here, I have 4 in the abacus, right? I have 4 in the abacus. 1, 2, 3, 4. I have 5 fingers. See that? I have 5 fingers. I'm going to add 2. So I add 2, but I'm not going to cut my hand off. I'm not going to cut my fingers off. I got to remove these 3. So I'm going to use these 3 to take it away. I don't know if you want to do that. That's a little bit darker. But I was just thinking that. You could probably show the place value on that if you get a chance. Oh, yes. It's a little darker with my fingers. My son likes that kind of explanation. You don't want to chop your fingers off, so you just use what's out here, right? Because you got to do it again. And if you chop your fingers off, you can't do it again. So that's why you do this. Hey, G306. You can use fingers up to 99. Hey, Plasmo! Yes, the boys love it. You can, but then they're not going to be attached. Because if you cut them off, then it's all one and done. All right, so there's that way. So you could do that. I was talking about, I found different ways to figure out how to do things. And so, yeah, one of them was the fingers, but it is a little dark. What else? Oh yeah, you could use the package. The package is if I needed. So here, if I have 3. Is that all you needed? Do you want to take a picture of that? All right. Yes. Okay. 26 times 30. You want to do that? Okay. Hold, please. All right. Yes, not a problem, not a problem. All right. I guess it's just all us. Okay, how are we doing? Okay. Our question will push us forward. We are going to do multiplication. I need to find paper. I don't know what happened to my paper. Oh, here we go. Okay, here we go. So we do 26 times that by 330. Well, remember, G, what we're doing? We have to find our place values. Excuse me, what's our starting point? What's our starting point? Here it is. 26. That's not our, no, that's not our starting point. Our starting point is 4. 1, 2, 3, 4. That's our starting point. So when we look, we're going to count 1, 2, 3, 4. When we do multiplication, we're going to do distributive property. So we do 3 times 6. I'm sorry, 3 times 2 is equal to 6. 6 is a single digit. So what happens? We need to make this a double digit. So it's going to be a 0 and a 6. So that's how we have to remember. 0, 6. So we add the 6 here. And then we do 3 times 6. 3 times 6 is equal to 18. Carry the 1, carry the 8. That's it. So what's my final answer? Well, my final answer is 780. That's it. Because why? The reason why is because you count the digits. If you count your digits, the abacus will hold your place values. You don't have to worry about place values. You just need to know your multiplication table. You don't need to say 30 times 20, and you don't need to say 30 times 6, because the abacus keeps that track for you. Keeps track for you. The abacus keeps track for you. Yes. Does that counting always work? Yes, it always works. I've done many questions, and it always works. It always works with the single digits. So here's another one. Plasma, how are you doing on the plus 10s? I found out another way to explain it. Oh, good. Thank you. Gee, that was easy. That was easy. All right. Do you remember how to plus the 10? Where can I get a bulk of, let's say, 34 for my students this year? You can DM me and we can talk about it. This is my favorite form of... Oh, thank you, Sasquatch. Very good. Learning all 34 rules. Is it 34? I guess so, huh? No. Why would it be 34? I don't know. I don't know. I have to count it. Why would it be 34? 9, 2. That's too many. Does it help with mental math? Yes, it does help with mental math. Including combo. You shouldn't include the combo, because the combo can be anywhere. Because if you did 20... What do I want to do? 52 plus 8. You should not include the combo. Here's why. I like it that they show the place values in the blocks in the middle. I like it. They show it with the place value blocks in the middle. Yes. So I would not include the combo, because here's one, right? If we do this, 52 on the abacus, we add the 4. Then what do? We have the 8. When we have the 8, it's what? Plus the 8 is equal to plus the 10 minus the 2. So plus the 10, take away the 2. I'm going to take away the 2. I want to plus the 10 here. Is this part of your combo? No, because it's plus the 1 is equal to plus the 10 minus the 9. So we plus the 10 minus the 9. So Plasmo, I would not include a combo. I would include just the formulas that you have at hand. Does that make sense? Yes. Yeah. So now I got to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 18, 19, 20, 21, 22, 23, 24, 25, 26. It should be 26 formulas, because that includes adding and subtracting. 26 would be the total. 30 is too much, because and you don't need to memorize the reverse. You know what I mean? But as long as you understand how to do the 10s and the 5s, then you're golden. Because depending on the numbers and how big the numbers get, you're going to need to combine it all over the place. I like it. Oh, I'm saying, I like it when they show it to me, this explains why the abacus works. Yes, the abacus works really well. It's just one of those things that you have to make sure you understand the fact families. The fact families become very crucial to understanding. One of the things that we understand is one fact family is adding of the 5. And then the next fact family that we need to understand is this one here, is what I was talking to Plesmo. Plesmo understands the fact family of the 10s and the 5s, and then they can be interchangeable. Yeah, it's really quite interesting on how everything makes sense. So that is adding of the 5. Now what we could do is we can minus the 5. Now if you know how to add, you will know how to subtract. So what we're going to do is we're going to start subtracting. Thank you everybody for joining, and my name is Lynette, and for those of you that are interested, I do have books available in my TikTok shop, and I do have books available in over here. My name is Lynette, and I've been teaching abacus for about 20 years and more. So everybody, I do appreciate everybody joining. Thank you so much. If you have any questions about abacus, let me know. And then what are we doing? What mathematical operation can the abacus do? This is it. Adding, subtracting, multiplication, and division. That's the only thing. It's the only thing it can be used for. That's it. There's nothing more. You can't do it for calculus. You can't do it for, I don't know how to do it for calculus because it's above my pay grade. I don't know calculus. I apologize. I don't know calculus. And there we go. Square roots. You could do square roots. You could do square roots. But it's still calculations in your head. You could do exponents, but it's just multiplication, really. Square roots is just division with the same number. So, I mean, you can, but it's questionable. Okay, so how long did it take you to master the abacus? Master, I think maybe a couple of years. I haven't learned that. Try adding 1 to them, failed. Oh, probably a couple of months, maybe 6. For all of the abacus that we needed to teach, probably about 6 months. And that goes all the way to division. I haven't... Can you give me an example of subtracting fractions, maybe? Well, fractions is just division, right? So you would have to divide it first. But adding and subtracting subtractions is algebraic, and that's not what abacus does. Oh, so you did what? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 6 plus 7 plus 8 plus 9 plus 10, 11, 12, 13, 14, 15, 16, 17. Huh. Yeah, you could do that. Well, that's really interesting. That's one way to practice. That's one way to practice is counting from 1 to 100. I only went to 17 though. Whew. That would take a long time. That would take some time for me to maybe I'd do that one day. But then I don't know if people would understand if I did that as a post, you know? But yeah, because yeah, that's a good idea. That's a really good idea. Too fast. All right. It's a different way of thinking. But then you're going to start seeing that you're going to start memorizing numbers, right? Because then you're going to know how to add it. But yeah, it's interesting. Okay, sorry. Sharon, is that... So Cal, my Ken, I don't think I can add and subtract fractions. That's more of algebra. I can show you fractions, but I can't do adding fractions. Okay. So we're going to continue on. You know what happens? Oh, what was the number? I think the number is... then you can do minus. You could also do subtraction. I think it's 50,000 5,050 and then start subtracting it. So it's 5,000, I think that number is 5,050. 5,050 and start subtracting it. So you get 1 minus the 1. Oh, minus the 1. Minus the 1, right? Minus 2, minus 3, minus 3, minus 4, minus 5, minus 6, minus 6, minus 7, minus 8, minus 8, minus the 10, minus 8. Yeah, you could do minus. Get the wrong answer by 17. Oh, yeah. You know, I don't know. Do you write it? I would suggest write it out. As opposed to saying it out loud, I would write it out. So, like, and then you can keep going. You know, get a printout, and then it'd be like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. And then I would try to print it out. And then I'd use the abacus to help me keep track. So it'd be 1 and then 2 and then 3 and then 4, 5, right? And then 6. Yeah, but it keeps but it's time consuming. Oh, I see. Get a printout. Print it out. Oh, maybe I should do that. Get a printout. Write it out and just have it print. We could do that. Not like and then afterwards you could put the answers, right? So we're at, I don't know where we're at. You could do that. You could do 1, 2, 3, right? That's 3. You could do 6 and then 10 and then 15 and then what? 21. We have 28 and then we have 30. Take away 2. 36. You could do that too. This is so entertaining. Hopefully I'll see you. Oh, thank you, Jans. I didn't know you're still here. Yeah. Add the last number to get the number. Yeah. Add the last number. But see, yeah. But you have to write it out. Trying. I don't know. I would probably print it out and then I'd use it. I'd use it to help you track it. So this would be 9. So plus the 9 minus the 1 and then plus the 10. Plus the 10. You know what I mean? Yeah. That is a very good exercise. But instead of trying to visualize it or verbalize it, I would print it out. I was still here, very in a trance, but I have to go. Well, thank you so much for joining. Thank you so much for joining. Right, 36. Yeah, so 36 is 36, right? Plus the 10 minus the 1. That's the 9. And then we have to plus the 10. Plus the 10 is plus the 10. Yeah. Yeah, that's a very good exercise. It was one of the, back in the day, that was one of the warm-ups that we did. Go all the way to 100. But is this not just simple math with extra steps? No, it is not simple. It is not simple math with extra steps, because when you get to bigger numbers, right, then those extra steps will be beneficial. So I don't know how you do this, right? But see, the idea is if I have 1,357, I don't need to memorize anything. So what I do is I just add the 2, add the 4, right? Add the 3, add the 1. You could do that too. What is an extra step? Well, you know, Plasmo, this is what I got. You didn't vocalize the rules though. Vocalize rules. No, no, I don't. Sometimes I think I get it. I get to the point. Yeah, yeah. So like something like this here, something like this. You could do this, right? The reason why I show you the simple math is to show you how it is on the abacus. But then you can see it scale. So here's the question. We have 23 take away 19. We have 23 on the abacus, 23 on the abacus. I'm sorry, 23 on the abacus, right? I want to take away 19. What does traditional math do? Traditional math does take away the 1 and then you add the 13. You have to memorize 9 and 13. 9 and 4 is equal to 13. You need to know this. So what happens? Well, on the abacus, you just need to memorize 9 is equal to minus the 10 plus the 1. That's all you have to memorize. And then you could do it again. So, but here in mainstream math, you do 35 on the abacus. Oh, sorry. So I have 23. So all I got to do is take away the 1 and then take away the 9. That's all I got to do, right? So my final answer is 4. But it's extra steps because the numbers are starting to get bigger, right? So we could do it again with the 35. If I have 35 with the abacus, and then what happens in mainstream math? You take away the 2, right? And you add the 15. You have to memorize that 6 and 9 is equal to 15. You have to know this, right? That you count up. But what do we do on the abacus? Well, the abacus, we have 35. We want to take away 2. We want to take away the 9. Take away the 10 plus the 1. Bingo. So we have minus the 9 is equal to minus the 10 plus the 1. Do you see how simple it is? But mainstream, I mean, that's why it's difficult for those people that don't understand. You got to go simple first to understand. You either plus or minus on the problem. Yes, exactly. So we have 86 on the abacus. We have 86 on the abacus. And then we want to take 59. Take away 5, take away 9, right? Take away 9. Well, remember, we had to minus make this a 7 in mainstream math, and then you have to add this as 16. So 16, you need to know that 7 and 9 are a pair. Because 7 and 9 are a pair, then you know. But in abacus, we just need to take away the 5, take away the 9. Take away the 9 is minus the 10 plus the 1. So my final answer is 27. So what did I do? All I did was minus the 9 equals to minus the 10 plus the 1. They don't let us use those in school. No. If they don't let you to do it in school, you can do it at home. You could still do it. You could still do it in your mind. You can see the pattern. Abacus is all about the pattern. Abacus is all about number patterns. You see that there's a pattern here, right? If they give you this number, then you're going to be like, okay, 47. I have 47 on the abacus. You can try to imagine it, or you could practice it. Take away 1, take away 9. Take away 9 is minus the 10 plus the 1. So my final answer is 28. So, but it's one of those things. Oh, that's the other thing. So plasma, I was like thinking about this. And I was thinking about what we're trying to do. So we have 8 on the abacus. No, we have, what was it? It was, let's do the reverse. I know someone that does it in their head, and it always amazes me. I don't know. I'm having completely changed the way I look at the problems from what I learned. Yeah, right? I'm having to completely, yes, it is a different way of thinking. It's a different, if you keep your mind open, it's a very different way. But once you start understanding it, once it makes sense to you, then it'll be easy. It's funny. I found this one.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Do you remember, I don't know if you've ever watched Cars, but Doc Hudson is one of the an old-timer racing, and he actually races on dirt, and he was talking about how to drift. And so it was just funny, and I was like, oh, I remember that. You have to go left to go right. And then what's his name? Lightning. He's like, oh yeah, in opposite world, no thank you, because that really means thank you in opposite. Anyway, it's just funny. Anyways, so, so here, it's easier if I stop trying to solve the old way. It's funny soundbite. Thanks. Accurate, right? Oh, okay. So here, this is what I was looking at this. When we were looking, here, this is an interesting way. We have 9 on the abacus. 1, 2, 3, 4, 5, 6, 7, 8, 9. You might get a kick out of this, Plasma. I was so happy you're here. So we have 9 on the abacus. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We got to add a 9, right? Guess what? We can bring it together like mainstream math. That's what they do, right? But guess what? In abacus, they already know that if I want to make a 10, all I got to do is rearrange it. I just got to take this 1 and bring it here. Now I have 10. Do you see that? So what abacus is doing is organizing the bricks. So this is 10. So what do? I took away the 9 to make this 10. Make sense? Oh, I thought that was brilliant. We could do it again. So we have 2 on the abacus, right? 2 on the abacus, 2 on the abacus. We have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then guess what? We don't want to combine it because then it'll be messed up. What we're going to do is we're going to organize it. All we got to do is take away this 1. That's this one right here. And then we put it over here. So then we add the 1. So my final answer, I took the 1. Yeah, you take the 1. And then my final answer is 11. Now it's organized. Do you see that? Isn't that cool? So we could do it again with an 8. So what do we have? We have 4 plus 8. 1, 2, 3, 4, right? 4. 1, 2, 3, 4, 5, 6, 7, 8. What do? 1, 2, 3, 4, 5, 6, 7, 8. This is 8. What do? I have 4 on the abacus. Guess what? To make a 10, all I got to do is take away this, right, from the 4, and then I'm going to reorganize it to do that. So I take away the 2, now I have a 10, so I add the 10. Yeah, that was a good find. And I was trying to figure that one out. Thank you, Sunny, for the follow. Right? Does it make sense? So what we just did is we organized it. We don't combine it and then try to figure it out. What we did is we take it away. Yeah. We can do it again with the 7. 3, 4, 5, 6, 7. Right? And then we have 8. 1, 2, 3, 4, 5, 6, 7, 8. We know 8. We have 8 here. But guess what? We want to make this a 10. So we have 7. And we have 8. So we have 7 and we have 8. We're going to take away this 2, take away that 2, and we're going to add it to here to make it a 10. So we're going to add the 10, and that's what we're going to do. Minus the 2, right? Take away the 2 from the 7. So then I can see it. It's rearranged. 15. Now it's 15. 5 and 1. What do you think? I thought that was cool. Rules. Yeah, it's all about the rules. It's all about compensation. In one of my friend was mentioning that they're starting to teach the kids how to do compensation, but I think Abacus does it really well. Compensation means that they're taking away the number and then they add it here. But I don't know how they're explaining it. I don't know how they explain it in mainstream. So even if we did 18, I have to hang on to the rules. Yeah. So we have 8, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. And then we have 8 again. 1, 2, 3, 4, 5, 6, 7, 8. So we know that we have 8 here. And what we're going to do is we're going to rearrange it, and we're going to make this into a 2. How do they do, how does, oh, I think mainstream math, they do it the other way. They take it from here. I don't know. I don't know how they do it. I don't know how they do it. But that's how we do it in Abacus, because we have to make the bottom number a 10. That's what we do. I learned how to do most of my basic math in Romania in 2000. That's really cool, Nick. Yeah. I wonder, and in Abacus, I think we take the second number, and that's what dictates whether or not that's what it is. It's the second number that dictates it. It's not the first number. I think mainstream math has it wrong. I think mainstream math talks about the first number. Nick, did you learn the abacus? I don't understand what Romania basic math is. Is there a name for that, or is it just regular? Oh, using the abacus. I see. Is it a 10 bead or is it a 5 bead? This is a 5 bead. 5. So 1, 2, 3, 4. This is a 1 and 4. There's a 10 bead. Oh, that's very interesting. The 10 bead, the interesting in the 10 bead is a 1-to-1, because there's no formulas. Do you use formulas? Yeah. The Soro, R-O, S-O-R-O. No, a 10 bead is different than the Chinese abacus. Yeah. Nick didn't do the Chinese one. He did a 10 bead. So the 10 bead is something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. But in Japanese, we do formulas. So there's like formulas and concepts that we do. So we need to know that 8 and 2 is equal to 10. Yep. Okay. How are we doing? All right. Yeah. No, basic concepts, adding, subtracting in second grade. Oh, that's interesting. That's really interesting. Because you can actually multiply and divide on the abacus. On the you could do it on the, you could do it on yours. You could do it on the 10 bead as well. Because it's just counting beads, really. But what we do is, in the Japanese abacus, what we do is, there's formulas involved, so it's easy to add and subtract on it, and then we can get into bigger numbers. Yeah. Interesting. Very interesting. Do they still use it, or is it now no longer in Romania? That's the other question. Because I noticed some Chinese people, not everybody in China knows how to use the abacus, and not everybody in Japan knows how to use the abacus, as well as not everybody in Korea. No, they stopped using it. That's too bad. That's too bad that they stopped using it. I believe it's the greatest thing. I don't know why they're so influenced by Eurocentric math, because I think Eurocentric math is going the wrong way. Yeah, that's sad. Only 2 countries teach this, not counting China. No. Malaysia, India, China, Japan, Korea. Yeah, it is too bad. Even if it's a 10 bead or a 1 and 4, I think visualizing our numbers, being able to see the numbers, I think does huge like breakthroughs. You can see so much more instead of trying to imagine in your head, and it's too bad. I'm sad it's no longer. I'm sad that it's not there in Romania anymore. But that's why I'm here. Every child should learn the abacus. Helps concentration. Yeah, that's why I'm here. I'm here to show the matrix what an abacus is. Thank you, Nick, for joining. Thank you, Nick, for joining. Yeah. And you know what, Plasmo? I was just saying, I have a few people that are older, and they're keeping their mind active with the abacus, and they're seeing that they're actually being able to think a little bit faster. So it's bringing back their little nuance You know, they're little synapses to come back again. So just being able to do adding and subtracting on the abacus, or even multiplication and division, even doing this little bit helps you keep your mind active. Gotta write my dissertation. Oh, what? Gotta get back to writing dissertation. Can I ask what your dissertation's about? That would be probably above my pay grade. Okay, let's do that. I would like to figure out how to write a dissertation for abacus, but it is way above my pay grade. All right, what do you have? Yeah, because I've been teaching abacus for about 20 years, and so I want to be able to do research on it, but I don't know. All right, what are we doing? We're gonna do this one. It's because it is a two-step equation. So we have 56 and then 47. So we have 56 on the abacus, 56, right? We add the 4, and then we add the 7. Ha! So we add the 7. What's 7? 7 equals plus the 10 minus 3, right? This is what I'm saying. The combos are not going to help you. That's what I'm saying. Memorizing combos will not help you. No 10. Add the 7 plus the 10. Right. We're going to do the 10 first. Okay? So plus the 10. What do we do? Plus the 10. 1, 0. 1, 0. Plus the 1. Plus the 1. What are we going to do? Don't think of it as 100. Think of it as plus the 10 minus 9. Think of the formulas as position agnostic. We're looking at this number right here. We want to add the 10. We're always going to be to this one over, no matter what. We're always going to go to the left over. So when we look at it, we take away the 9 plus the 10. 10 just means 1, 0. That's all that means. 1, 0. I need to move up. There we go. That's what that means. 1, 0. We're just moving it over. 1, 0. So then we need to minus the 3. Take away the 3. Minus the 3 is equal to minus the 5 plus the 2. Minus the 5 plus the 2. So my final answer is 103. I think of plus the 10 minus... Yes. Think of it plus the 10 minus the 9. Hello, Pap. Thank you so much for sharing the live. Yes. So when you're thinking of it, don't think of it 100 because when you get to more, I don't know, let's do like 56,000 plus 47,000, then you're going to get really messed up. You're going to think of all these. But if you think of it, 56,000, right? When we talk about it, we're only talking about it here. So we add the 4. We're going to add the 4. That's all we're doing. We're adding the 4. Then we add the 7 here. To add the 7 is plus the 10 minus the 3. Plus the 10, right? Plus the 10 minus the 3. Minus the 3. Minus the 3, and then plus the 10. Need to plus the 10. 1, 0. 1, 0. So 1. Can't add the 1 here. So what do? Plus the 10 minus the 9. Plus the 10 minus the 9. Does that make sense? So then my final answer becomes 50,300. That's why we bring it down to manageable chunks. Don't say 100 minus 90. Think of it as 10 minus 9. Yeah, think of it 10 minus 9. That's the formula. Yeah. Because then it becomes scalable and it doesn't matter where you are. But then that's what I'm saying. Combos will not help you here. right? If you just memorize the combos all over the place, then you're memorizing. What I'm trying to get you to do is understand concepts. If I can take away the 3 here, or if I could take away if I can add the 1, understand the concepts, and then you could Tetris your way through. So here is my 3, here is my 1, and that's how they're connected. Connect them. Don't memorize. Don't memorize them as groups, because there's no point. Connect them like they're dots. Yeah. Connect them like they're dots. Don't memorize the chunks, because then you go back to the same problem in mainstream math, which is the bigger the number is, the harder it is. Make them into smaller chunks that's easier to understand. Because the brain is only is capable of a lot of things, but it's capable of a lot of things because of small focus. I don't know if that's the right focus. Yeah, something like that. So when we're talking about it, yeah, because it becomes scalable. Oh, yeah. Any other questions? That's a good question. But that's the one thing, like, just the two-step equations are because it can then be multi-step, and because it's multi-step, it would be like algebra. So we have okay. This will be my last question, and then I'm going to head out to go get some dinner. And then we do, okay, 2. Let's do the first one. 99. When we add the 1, right, we have to pay attention to what number we're doing, right? We have to add the 1. When we add the 1, what do? Plus the 1 is equal to minus the 9 plus the 10. Minus the 9 plus the 10. 1, 0. 1, 0. We do it again. Minus the 9 plus the 10. 1, 0. So my final answer is 100. Yep. So we do it again. It's the same thing. You keep doing it until you can't do it anymore. So adding the 1 to here, what do? We have to plus 1 is equal to minus the 9 plus the 10. Minus the 9 plus the 10. 1, 0. 1, right? 0. So what do? We have to plus the 1 minus the 10 plus the minus the 9 plus the 10. 1, 0. We do it again. Plus the 1 is equal to minus the 9 plus the 10. So your final answer is 1000. Yeah. So you keep doing the number until you can't do it anymore, but you have to really track your numbers. What were the other problem you were doing? Oh, I was doing a two-step equation. A two-step equation, because you need to know how to make a 5. That's your fact family. You need to know your fact family of 5s and your fact family of 10, and then you combine the two, so then you can get the answer. That's what that was. I lose it in the middle. Yeah, if you lose it in the middle, use your finger to keep track. So I have 99 like that, right? So I use my finger to keep track. So minus the 9 plus the 10. Minus the 9 plus the 10. Minus the 9 plus the 10. That's what I would do. You know what I mean? So use your fingers to help you. Yeah, so this one was called a two-step two-step. The reason why, well, multi-step, because you forget the first. You have to understand how to get this first, and then you figure out how to get this. It's like a little puzzle. It's easy when I do it. You use your fingers to help you track. That's what I do. I use my fingers to help me track. So even like here, I have 5,600, right? Plus 4, plus 7, plus 7, plus the 10, minus the 3. Yeah. Yeah. And then again, I would verbalize it, right? Because I can hear myself, and if I can hear myself, then I'll do it. Thanks so much. Yeah, not a problem. All right. Other than that, there's still 60 people here, but everybody's very quiet. But I am going to head out. Thank you again for coming. Thank you so much for Plasma for joining. Have a good meal. Thank you. It is going to be a good meal. Yeah. Bye. Bye, Max. Max, did I answer your question? I'm sorry. I apologize. Was your question answered? It's also a little bit more intermediate. Okay, good. This is more intermediate or advanced. I guess it would be advanced, right? Because it's multi-step and it's very close to algebra. Okay. But thank you again. Thank you everybody for joining, and I will see you guys all in my next live. I'll probably be on later tonight. I came on early just to try to get some stuff going. But yeah. Oh, Plasmo, just so you know, I have my introduction to Abacus for adults. Oh yeah, I want to show you my here is my, let me see if I could find it. Here is my book. La la la, where's my book? Hold on, hold please. It's gonna look like this. That's what it looks like. Oh, I don't know if you can see that. There's my new book. Basic Math Abacus for adults. Oh, hello, and Rook. How are you doing? How's it going? Thank you so much for checking in. Thank you for the tiny diny. Thank you for checking in. That's awesome. Thank you so much. I'm really excited for it. I'm really excited for this. It's right now in review, and it will be published in probably about 3 days or so, 3 or 4 days. So I'll let you guys know when it's approved, but I'm really excited. Yeah. And it has all the activities and stuff. Oh, I'm so excited. This is my 14th book. It's much better now. Yep. Okay. Thank you so much. Thank you so much. All right. For those of you, I do apologize. I am going to head out. What? I checked if you're live before anyone else. Oh, I'll be getting their book. Thank you so much, Enrook. I appreciate that. But I'll be on later tonight. I was gonna go out for dinner, and then I'll be on later tonight. But that's the plan. Probably 8 or 9 Pacific Standard Time if you're around. But it'd be good to see you. Thank you so much for the donut. Thank you so much for the donut. I appreciate that. Yeah. All right. But I am going to sign off, and I'll see you in my next live. Probably in a couple of hours. Thank you. Bye. I got notifications set ready. You're so funny. You're so funny. Thank you so much. I appreciate that. Thank you so much. I'll see you. Bye.